So anyway, yesterday and the day before, we took empirical formulas and we turned those into mass percents. Today we're going to go back the other way. We're going to use mass percent data to determine what the empirical formula of a compound is. And the way we do that, and we're going to do it several times, the way we do that is we convert the mass percent to grams. So just like if you had 70%, that would be 70 grams. So when we went from empirical formula to mass percent, we said if you have 1 mole, this is how much it would weigh, and you use the periodic table. When we're going back the other way, we say if you had 100 grams, this is how many grams you would have. So we're going to turn the percents into grams. So 70% will become 70 grams. 30% will become 30 grams. 18% will become 18 grams. So the entire compound will have 100% turning into 100 grams. Okay? So let's go ahead and do that. And then once we have the grams, we're going to convert the grams to moles. Then we're going to use a ratio of the moles to figure out what the little numbers are, what the subscripts are in the formula. So let's do that. So first one we're going to do is a compound that contains carbon and oxygen. So the first thing we need to do is write down what the elements are, carbon and oxygen. And then 27% carbon becomes 27 grams of carbon. And 73% oxygen becomes 73 grams of oxygen. Does that first step make sense?
Yeah.
Okay. Next, we're going to take those grams and we're going to convert them into moles using the T-chart. So, our 27 grams of carbon, we're going to convert that in from grams of carbon to moles of carbon using the periodic table. So, you will need a periodic table and you will need a calculator. Put some numbers in. So if you haven't figured it out already, do that.
Time to bring out the pretty boys.
Time to bring out the pretty boy. Punch some buttons in your micro calculation device.
Where's the pretty one? There's one. All dressed up for the ball. Me? I'm Jesse. Human. From the planet. Homo sapien. Wait, that's not how you say it. That's like homeostasis. I'm a homeostasis. I don't have a calculator though. I do have a communist manifesto. My backpack though. It's okay.
No Mein Kampf.
Okay, we can read this.
You got a manifesto?
Yeah, I carry it with me wherever I go.
Okay, so the periodic table tells us that in 1 mole of carbon, how many grams of carbon do we have? 12. Okay. This whole T-chart thing that we learned about in October, we're going to do it a lot in February. This is the whole bulk of stoichiometry. I reminded you back in September and October that if you mastered 1 step in October, then mastering 5 steps will be easy in February.
Oh,
and now we're at that point. We're going to be doing some more math using the periodic table, converting moles to grams, and so on. So back to this. If we have 27 grams of carbon and 1 mole of carbon is 12 grams, then how many moles of carbon do we have? 2.25? Sounds good. Again, if you round at weird times, perfectly fine. If you round when you're different time than your neighbor does, perfectly fine. Okay, so we got 2.25 moles of carbon. What about oxygen? Oxygen, for every 1 mole of oxygen, the periodic table tells us there are how many grams? 16. That means, some of you have already done it. Take a minute if you haven't done it yet. Then Weston will give us the answer, but not quite yet. Take another minute and see if your number agrees with Weston. Again, we're just practicing this the whole period. The whole day we're just practicing this. So tomorrow, when we have a worksheet, you can just bang the whole worksheet out in class and be good at this and then ace the quiz.
Yeah. What days is it on?
Right. It's just going to be a little 20-point job.
Okay.
But it's going to be everything we've done so far. Empirical formula, percentage to empirical formula.
Oh, I don't remember how to do this.
Okay, so if we have 73 grams of oxygen from our 73% of oxygen, then how many moles of oxygen do we have? Less than 4.56 moles of oxygen.
So, okay,
Yes.
do it divide.
Yes, because we have grams. Remember, from using a T-chart, if we have grams up top, we bring grams down below. So grams to grams, then the grams cancel out, and we have a fraction, 73 over 16. Okay, so that's step 2.
Okay.
Give me a thumbs up if you're with me so far. Like most of us. All right. The next step is to look at the ratio of the 2 moles. And that's going to give us the numbers that belong as subscripts. Make sense? So divide the big number by the small number, and that's going to give us our ratio.
Is the top number 2.25?
It is.
It's 26.
Sorry. I lack my natural light. I do not lack the fluorescent lights. Right. Yes, big over small. We're looking for whole-ish numbers. Yeah. Yeah. So about 2 to 1. So that 2 to 1 basically means, guys, that the number in front of the carbon should be a 1. Sorry, after the carbon, and the number after the oxygen should be a 2. So the chemical is CO2, carbon dioxide. 1.
Wait, so why do we put the 1 in front of the carbon?
Because it's the small number. It's the one that has less moles. And oxygen has twice that, so oxygen gets a 2. Yeah. I got the subscripts, 1 and 2, from the ratio. There is twice as much oxygen as carbon, so I put a 1 and a 2.
Oh, because it's like evening it out.
Yeah.
Okay.
So that is the empirical formula. The empirical formula literally is the formula of the compound from the data. This is the data. This is the empirical formula. Can you see green in the back row?
Yeah. You can't see the blue though, whatever that color is.
Okay. Okay. Do like this. Move around. Okay? So, any questions so far before we do another one? Would it help if I just turn the lights on?
No, I don't like it.
Don't like the lights? Better to take a nap with the lights off. Okay. All right, so that's how we do it. Step 1, turn the percentages into grams. Step 2, convert the grams into moles. And then step 3, just find their ratio. So let's do another one. Sodium and chlorine. You can probably guess right away what this one's going to be. But sodium and chlorine. So sodium is Na. Chlorine is Cl. 40% sodium turns into 40 grams of sodium. 60% of chlorine turns into 60 grams of chlorine.
Okay, when I put like 0.4.
find the molar mass of chlorine and sodium, so you can do their T-chart and convert those to moles.
Then we would divide 40 by 20%. And I got 1.7. More than 60.
Mr. Byers, in the first problem, where did you get the second, the bottom right box? I kind of,
Bottom, this box here and this box here.
yeah.
Periodic table.
Oh.
The mass from the periodic table. So I looked at carbon, carbon was 12, oxygen 16.
Okay.
So that's where we are right now in our second exercise. We're finding the molar mass of sodium
1.7.
and the molar mass of chlorine. So sodium has a molar mass of what? Anybody? 23? So 23 grams in 1 mole of sodium. And chlorine has a molar mass of 35 grams of chlorine in 1 mole of chlorine. So what does that give us for moles of sodium?
1.7.
1.7?
Yeah.
And for moles of chlorine?
1.7.
1.7. So like I said, you probably already figured out that the ratio here is 1.7 to 1.7.
So it's 1 to 1.
So it's 1 to 1. 1 to 1. Or our favorite, put it on your French fries, sodium chloride.
Neat.
Yeah.
So, will it ever ask us to like, what that means?
Well, that was chapter 7. That was that was B1. That was unit B1. Okay. So let's do another one together.
Yeah.
This one's going to have 3 elements. Oh no. Okay. So this one's going to have magnesium. It's going to have sulfur, and it's going to have oxygen. There's 20% magnesium, which we're going to turn into 20 grams of magnesium. There's 40% sulfur, which we're going to turn into 40 grams of sulfur. And there's 27 grams of sulfur. Okay. Yeah. 27 grams of sulfur. 27 grams of sulfur and 53% oxygen, which we're going to turn into 53 grams of oxygen.
Okay, so it's 27?
27. 27 grams. Sorry, hold on, back up. 27, 27.
Okay. 2027.
2027. Thank you. Don't cry. Sometimes even your heroes make mistakes. So 20 grams of magnesium and 27 of sulfur. So see if you can take it from here. See how far we can get on our own from here.
Oh yeah, look. Have your socks. How do I have people in there? Yes. You wanna help us? Clap row? No. Definitely not. Cut out. Okay, last night I fell asleep on my laptop. gonna collab on Google Docs tonight. And so we all have to each choose like a different color so we know who wrote what, and then we can like. Okay, I'll be black because I'm the original. Blue to keep gender norms. How do you I'm not sure.
Okay, if you got the moles, raise your hand. Awesome. Okay. Back row. What's the mole of Mg? Anyone in the back row? So when you divide 20 by 23.5 or 24, what did you get for the moles? 0.833?
Yeah.
All right. Moles. Middle row. What did you get for sulfur? Sorry, third row. 0.84. And second row. What did you get for oxygen? 3.31. All right. So obviously, these two are going to be the same. So whatever subscript you have for magnesium and sulfur, they're going to be the same because they're the lowest number and they're the same number. What happens when you take 3.31 divided by 0.84? Yeah. So these guys, magnesium and sulfur, are going to be a 1 because they're the smallest numbers. And oxygen is going to be a what? A 4. 3.9 rounds to 4. So this chemical is MgSO4, magnesium sulfate. 53 divided by 16, and then you divide the big number into the small number by into the big number. Yeah. Okay. Okay, give me a thumbs up if this is making a little bit of sense. Okay, cool. Next page is practice for you. So, are there any questions before we do our practice? Jesse.
So, if we do 3-step ones like that, are they always going to have the 2 be the same? Like, what happens if they're not the same?
Then you'll still look at the lowest number. The lowest number will still become a 1, and everything else will be multiples of that.
Okay.
Other questions? All right. So here are 4 exercises for you to work on. I'm going to turn the lights on.